Welcome everyone to part 2 of writing equivalent expressions. Okay, part 2. Let's get going. So let's see how many examples we can do. Hopefully a lot. So let's look at a rectangle this time. Last time we looked at an isosceles triangle. And I'm going to give you the length and width of a rectangle as algebraic expressions. So let's say we have the length of this rectangle is 6x plus 9/4. Ooh. And then we have the width as an algebraic expression as 4x plus 3/4. Okay, so you're given that information. And then I want you to write and simplify. So two things. An algebraic expression for the perimeter of this rectangle. Okay, first thing, perimeter. All right, so in your head, when I say perimeter, you should have an idea, no matter the shape, what has to happen when we find perimeter of a shape. Well, that means how much if I were to walk. Let me go again. If I were to start here, and I walk this way, and then I walk that way, and then I walk that way, and then I walk that way. How far have I walked? That's the perimeter. So I'm going to have to take this side and add it to this side, and add it to that side, and add it to that side. I have 4 sides to add up. Oh my gosh, and I know the length already of this rectangle, which means that that's going to be the same up here. And I know the width, so I know this is going to be the same as over there. So, my expression for perimeter is going to be 6x plus 9/4 plus 6x plus 9/4. Because those, remember, that was one length. Here's another length. Plus, now I need the width, 4x plus 3/4 plus 4x plus 3/4. Oh my gosh, I can barely even fit it on the screen. So I have my lengths, I have my widths, and there would be my written algebraic expression for the perimeter. Cha-ching! Whoa! Now hopefully we could actually simplify that so that if I do give you a value for x, we wouldn't have to plug it into this expression. We could plug it into a simpler version. So let's take a look at this thing and try to simplify it. So in my mind, I see, oh my gosh, I see a lot of terms. How many terms are in this thing? I have 1, 2, 3, 4, 5, 6, 7, 8 terms in this. Now those 8 terms, are they all like terms? No. So I'm going to go ahead, because addition is commutative, I'm going to move some things around. So I'm going to get all the like terms up front. So I have a 6x, which is also added to another like term of 6x, which is added to another like term of 4x, which is added to another like term of 4x. Out of my 8 terms, 4 of them were like terms. So if I add up all those, how many x's do I really have sitting there? Well, I have, if I look at all the coefficients, 6, 6, 4, and 4, if I add that up, 6 plus 6 is 12, plus 4 and 4, so 12 plus 8 is going to be 20 x's. So does that whole expression for perimeter simplify to just 20x? No, I still have plus something else. And that something else is the constants in my expression. I have some constants up there. So what are my constants? Well, those are all the beautiful fractions. Improper are some of them. So I have 9/4 plus 9/4 plus 3/4 plus 3/4. And this should actually make you super happy when you're adding them, because they're already common denominators. So if I add the numerators, how many total fourths am I going to have here? So 9 and 9 is 18, plus another 3 is 21, plus another 3 is 24. So this is 24 fourths, which is improper. So So if I take 24 and divide it by 4, I get a whole number, and that turns out to be 6. So the perimeter of this rectangle went from this up here, this, oh my gosh, 8-term mess, to a simplified version of just 2 terms, 20x plus 6. So if I say, let x equal 5, what's the perimeter of that rectangle? Would you want to plug it in to that first expression or the second expression? You'd want to plug it in here, because all I'd have to do is take 20 times 5 and add 6. And that'll give me the same answer as plugging into the top expression. Weird. Okay, we're going to work through one more. Same rectangle. Let's say this time with the rectangle, I ask for an area expression. Area. How do I find the area of a rectangle? Base times height. Okay, so let's just write an expression. We won't simplify it. Let's just at least write one. So how can we get area? We need the base of the rectangle. Are we given that? Yes, we are, people. 6x plus 9/4. So I'm going to write that out. 6x plus 9/4. That's my base. And since it's being multiplied, I'm going to put it in parentheses because there were 2 terms. It's being multiplied with the height. And the height is 2 terms also. What was the height of that rectangle? It was 4x plus 3/4. So I have my base of my rectangle times the height of the rectangle. And that is a algebraic expression, not simplified yet, but an algebraic expression describing the area of that rectangle. So I will see you in class on Wednesday, Thursday for more practice with these algebraic expressions.